Ultra Engine unlocks the full power of your GPU to deliver up to 10 times faster performance for your games. In this video, we're going to talk about the glTF modeling pipeline. Now, Ultra Engine also imports wavefront OBJ files, and there are converters provided for FBX and Collada file formats, but glTF is really the modern way to do things. It's such a great format because it supports animation. It has a really well-defined PBR material system. The integration in Blender and other tools is really good. So that's what we're going to focus on. We already have our model loaded in Blender, so let's export it for use with Ultra Engine. Just go up here to File, Export, and then select the glTF 2.0 exporter. This comes with Blender. 3D Studio Max also has a nice glTF exporter, and other tools do as well. And I'm just going to navigate to my models folder in my project here. And this is important. You can actually use any of these options, but what you really want is glTF separate. You want a separate glTF file and a bin file for binary data, and then you want your texture files to be separate files. It works out better that way. So let's export glTF. Now in the Ultra Engine editor, if we go over here to our models file folder, we can see that the model we exported is sitting here waiting for us, and we can double click that to open it. And you can see the materials came through perfectly. Let's get a good look at the material here. We can see we have the diffuse texture, normal texture, metal roughness map, emission map, as well as ambient occlusion. That's actually packed together with the metal roughness, which is a good way to do it because it's very efficient. Now, if I select the topmost node here, I can set up a collider by selecting one of these options here. Box, probably not. Cylinder, I don't like that. Convex hole looks good for this. If I want to get fancier, then I can go up here and go to the Tools Convex Decomposition menu. And this provides an interface to create a series of convex holes that approximates the volume of the object, like that. This is more detailed, but it's not as detailed as if I used the mesh itself for collision, which we probably would not want to do that because that's a lot of polygons, and that would make our physics slow down if something banged into that. So in this case, for this model, I would probably use just the default single convex hole. I think is probably the best shape for this. Yeah, we want to save the collider. We want to save the model. Yeah, okay. So this will actually place a collider file in the same folder as the model, but by default we have collider files. They won't show up in the asset browser just because it's kind of redundant. And when the next time we open it, we can see our collider is still there. There's one more thing we can do. If you look right here, you can see the textures are in JPEG and PNG file format. And that's not great because that doesn't use GPU compression. We can use a lot less memory on the GPU if we compress these textures using DDS or basis format. So if I go up to Tools and select Convert Textures to DDS, it takes a minute because it's compressing to BC7 format, and these images are actually pretty big. Okay, it says it modified 5 textures, and now all our texture format used in the model is DDS, and that's a lot more efficient. Let's take a look at the material. Yep, these are all DDS files now. And so let's save it now, since we made some changes to it. And now we have our finished model, and it's going to be a lot more efficient. And you might even notice it's actually going to load faster. You notice the loading is like pretty much instant now, because it doesn't have to load the images, the really big uncompressed images. One more thing, let's take a look at our image files before and after. So let's just look at the diffuse texture. We can just select the edit item here, and that'll open up the image file. So you can see in VRAM this thing takes up 5.3 megabytes, and it's in BC7 format. And let's take a look at I think it's a it's a JPEG file. So although JPEG is a compressed format on the hard drive, it's not compressed in memory. So the JPEG file actually takes 21 megabytes, so it's 4 times bigger. And it's just RGBA format there. So the DDS with BC7 compression is much better. For normal maps, we actually use something a little bit different. We use BC5, and the reason this doesn't look like a normal map, which is usually they're kind of purplish, is because this is a compressed 2-channel format specifically designed for normal maps. And in fact, this is the only compressed pixel format that you should ever use for normal maps. You should never use any other type of texture compression. So we reduced our texture memory by about 25%, and we made our model a lot faster loading. You can see how that would add up over if you had many, many models. And we learned how to add a collider to our model. It's also worth pointing out that Ultra Engine can save models in both glTF and OBJ files. And that means that your final game models can always be loaded back into your modeling programs. I think it's important to avoid any kind of black box file formats that make it so that you can't get your data back into the modeling program. So that's really convenient to work with.